Yeah, I'll have to leave at 3:30 sharp, okay, guys?
Got it. Thanks very much, Ryan. Okay, well, greetings to our colleagues in the electrical industry, and we're actually covering this topic live at the IEEE Industrial Applications Society meetings in Vancouver. We hope that the audio and the visual quality is good enough. This is what happens when you're working on the spot, but we thought it would make it more real to our colleagues elsewhere, that we try to stay up to the moment. We're with other people, so we like to think of ourselves as being here on your behalf. Obviously, it's always better if you're here, but short of that, you have this way of being up to the moment. And one of the reasons we're here, Jim and I, is that we are trying to put the gloss on this Educational and Healthcare Facility Electrotechnology Committee. So what I'll do is I'll let Jim summarize, and I think there's enough good audio quality that he can speak freely here, and we can start a Q&A on this. So Jim, you want to introduce yourself and then talk about this committee?
Yeah, I'm Jim Harvey, Manager of Electrical Engineering with the University of Michigan Hospitals. I'm also on the Power System Engineering Committee of the Industrial and Commercial Power Systems of IEEE, which is a subgroup of IAS, which is meeting here in Vancouver. We've been bringing up to this Industrial and Commercial Power Systems Department we brought it up for the first time about 6 months ago, that we wanted to form this new committee for representing the educational and healthcare communities. Committees is a form of organizational. There's the IEEE is an institute, there's Industry Application Society, and then Industrial and Commercial Power Systems is a department. It's just the way they're organized. And under the department there are committees. And we're trying to get a committee defined to represent the needs and wants of the educational community as a whole and the healthcare community as a whole. At this meeting here, we've had 2 or 3 meetings so far where we've broached the subject again. Yesterday at about 4 o'clock Vancouver time, we got the result of the meeting was we seemed to get general consensus that there will be support for us in creating a committee that we want to represent those 2 large segments of the commercial market. The final, I won't say final decision, there will be another meeting today at 4, which is the formal organizational meeting of the Industrial and Commercial Power Systems. Hopefully we walk out of that meeting with an agreement that they're going to form this committee. And if that's the case, then at our next meeting, which will be 6 months from now in Calgary, we'll be able to start meeting as a committee and presenting papers as a committee. And as things move on, then we can start broaching the idea of forming or proposing standards or recommended practices that the IEEE would then approve and publish that represent our specific and special needs. So I've been running off at the mouth a little bit here. You think you got an idea, you got a feeling of why we're doing what we're doing here?
Hi there. Sure, this is great. This is exactly what I wanted. So Giuseppe from the University of Rome, we're actually talking to many colleagues. This is a teleconference. You want to come over here, you can actually see what's the good news is
okay.
They stopped buzzing the tree.
I'll go get some.
Yeah. Why don't you have a seat here? Would you want to tell our audience what you do at the University of Rome? You're an important person in all this because you are comfortable and familiar and a driver in European building wiring practice, and we're going to be picking your brain and trying to get more. You can have a seat here, Giuseppe.
Okay.
You can talk a little bit more about some of the ideas that the Europeans electrical engineers use for building wiring systems. So you want to introduce yourself, what your area is, and then explain where we might be going with some of the driving some of the European, the IEC practice into the American suite.
I was catched to this
You were
conference.
right.
I will was a crossing just, but I have discussed a long time with Michael. Yes,
Make sure you see those there.
Okay,
You can see that
okay,
register.
thanks.
Fine.
So I discussed a long time with Michael about the possibility of to change the approach in the sizing and in the design the power distribution systems, and particularly to try to organize a new approach like a micro approach, so to avoid the point of view that I made to high distribution, but organize the distribution looking to the efficiency, local efficiency, local sizing of the loads, and so multiply the possibility to install power transformer substation, and so to limit the value of the short circuit current, and so the high level of exigency, and so it's possible to arrive to organize also a standardized, if it's possible, standardized sizing of local distribution.
So,
this is,
right.
Another approach is also to review how organize the sizing of the conductors, so the cross section, and consider not only the current but also the aging of the conductor, considering the kind of the insulation, and so so we discuss about the coefficient that normally has been accepted as a conservative choice in sizing the same conductors. And if we consider the aging, so and adopting the normalized value of the constant available in the literature, it's possible to see that the behavior of PVC obviously is poor in comparison to the EPR. Mm-hmm. So, considering the aging, could be obtained in the more expensive conductor organized and constructed with more expensive insulation. It's possible to adopt a more efficient sizing, adopting high value nearer to the ampacity, so, because the aging is obviously lower than the same value of the ratio of the ampacity. The aging is lower than for EPR, for instance, is lower than PVC.
So your work in the aging of conductors and their ampacity, that's a factor that doesn't really track in the fire safety in the NAC. So I think most of your work there is in the medium voltage area, right? I mean, that's where it strikes me that your work and research on the effect of aging on ampacity has the greatest effect. Yeah. Or is your study also gone into the building wiring system?
No, I think it's
both.
Both.
So
okay. In all situations, if we consider the aging, because you have remember that the current and the thermal behavior, has delayed in comparison to the instant behavior of the current or the square value of the current, and In this way, it's possible to evaluate the value of the steady state of.
Okay. So
is it always? It's always well.
So we'll probably do a special breakout on making that more meaningful. A couple of things that are probably meaningful to this audience in the time limit we have is that we're going to be approaching one of the orthodoxies, and I feel brave now that I've got Giuseppe here. The 125% criteria for establishing the size of a wire is one that we'll be looking at, and we might get some ideas out there. Those of you who were part of this effort last year, we actually did ask for some changes to Table 310.16. So Giuseppe has got some research, and we're going to try to get likely a little bit more granular in the way that table is constructed. So it's obviously highly technical. We do have Crystal Hunter from General Cable who will be helping us. We do have some draft proposals. So when we approach the 125% or the 80% rule, however you want to call it, there will be some scientific basis for it. And we know that the European, the IEC, the 60631 standard does permit designers to be a little bit more customized, or shall we say artistic, in the way they specify conductors. So that's about all the time we have for that one.
Yes.
And then finally, we would like to continue our drive to merge what we'll call global practice with the United States practice, and just some of Giuseppe's work. He's an entree as somebody who's involved in the European, the Central Electrotechnisch Normals, whatever they say, the CEN, right?
No,
You're also on the Italian electrical code.
Another very important application was considering the aging of the possible aging of the cable during the service. Is also important to organize the life loss monitoring. So for no little terminal cable, but the main the conductor of the distribution, we can organize the CAN towers. So is a very easy to product, very simple device that organize to consider the monitoring the actual aging during the service of the conductor. So considering the aging of the conductors could be a challenge.
Well, in a smart grid environment, it strikes me that we're going to have more data on a lot of that. So it strikes me that could be timely, especially in very large conductors or very large power delivery regimes. Having more information, and aging probably is something that might well be in there. Yeah.
So
we are running up against a limit here, and so
yes,
promise us after we get our calls out, and we're going to try to have, and we will try. We're going to let Jim finish here. So we'll try to get something in Rome, or at least a webcast in Rome, University of Rome. And I'm grateful for the time you spent with us here.
Thank you.
Thank you very much.
Bye.
Okay, Jim, you're back on again. You want to continue summarizing what we have? We got about another 12 minutes.
I just wanted to add in that if we succeed, as I believe we will, in getting this committee formed, we'll have the opportunity to start presenting papers at conferences that are directed at both those fields, the educational field in general and the hospital healthcare in particular also. And we'll give an opportunity for all of you who have the experience and the understanding of things from the way you operate your facilities that might be useful for many others doing a similar project and similar work. So our hope is that the formation of this committee will give us all an opportunity to exchange ideas in a more easily conveyed manner, and we can get it in print and let others see it. So I'm running off of the mouth here a little bit, but
Okay, well, we're coming in. Ryan, we're going to close here. I'll do a little closing statement. I've got, we have 11 minutes. Do you have any questions, Ryan?
No, that sounds reasonable.
Okay.
You're trying to form a committee.
Yep. So this was some of the basis for it. I thought this would be helpful. This was some of the PowerPoint that we tried to make our case for. It's fair to say, I think, that it's been conceptually cleared for months now, and that what we're talking more about are atmospherics, maybe process. I heard a lot of process. I didn't hear anybody say, I haven't heard anybody think this was a difficult issue, but just that now we have a follow process, the IEEE template for forming an organization within an organization. So we think that it will have a lot of consequence for our industry.
So if we're able to get this approved, which I'm sure we will, would you and others that might be on the call be willing to have your name added to communications about future conferences so you can see what information might be exchanged there, and if it's of interest, you might be able to participate in one degree or another? Would that be something acceptable from your perspective?
From mine, it would be.
Okay, wonderful. That's what we want to do, is just be able to exchange our individual experiences for the benefit of everyone else that might be having the similar issues and similar problems.
So I'll be on the hunt for papers, Ryan. Here's what we did.
Right.
There's some words that were said about me. I'm trying to get people to do papers, or at least posters. So we explained to them, this is Harvard University. We're trying to explain that these campuses are cities within cities. We get down to their organization chart, and these are the people here with whom we've been dealing with routinely for many years. And they don't have a place to go with an IEEE that's recognizable for their field, especially for campus power systems. This is the University of Michigan, obviously. We have the district energy plant. We have the hospital, and 33 million square feet. I believe that's the largest in the United States. Obviously, we have our organization chart, you know, my reporting structure actually is out into the world here, but a lot of these individuals here. This is now the hospital, by the way. You have a number of, and you might have maybe 50 engineers here at the hospital?
50?
Something like that? No?
Not that
25, okay.
I wish I had 50.
Okay. Here's Chapel Hill.
Common problem, eh?
Yeah. Galen Bishop is one of the drivers who was saying, geez, I'm getting measured on the metrics, the old IEEE 1366, is that the maybe I think 1366 metrics for reliability. There's no benchmark for him. We believe that you can provide something more bright line that's divorced from the residential numbers that are thrown into that index. Also, the index doesn't include weather. So to have campuses compared to an index which includes residences and doesn't include weather seems to me unfair to somebody whose salary adjustment is based on that performance. So here we have Berkeley. Berkeley's remarkable because we're trying to promote. I think Jim's going to. You want to say in closing remarks, and I'll finish up here, Jim.
No. I need to move to another meeting because one of the issues I brought up was presenting papers on the education and healthcare, and actually I have 2 papers I'm going to be trying to get presented at the Calgary conference dealing with some experiences we had at our hospital. So I want to make sure we get these first couple papers in at Calgary. We got a lot more slots available, so that's what Mike was talking about, if we can get some people to write papers.
We already got John O and David Schiff to do the low resistance grounding. What Ryan can offer, and we're going to offer you a chance, you and others in your capacity, you don't necessarily have to write an IEEE paper, but there would be a possibly just a poster session, or actually a tutorial about what you do and how your numbers, your operational numbers on elevators. I'd like you to be able to show us what.
Man that knows elevators. That's
right.
Oh, interesting subject to itself.
Hi there.
So
It sure is.
So
well, there's no time for you. This is our national teleconference.
It was a pleasure speaking with you, but as I said, I'm going to have to take off. So have a great day. Thank you.
You too.
Okay, so what's remarkable at UCal Berkeley is that they started low resistance grounding from scratch, and I believe they limit to 1,000 amperes, and you know that means have only 1,000 amperes of fault current, what that means for electrician safety. It also gives them early warning on cable failures or weakened or electrical leakage, so that's also helpful. Here's their organization chart. I've worked with Jerry for most of my career over there, so he can't get to a meeting, but he would come to an IEEE meeting and show us his numbers. Here's Texas, Austin, same situation, a large city within a city, their organization chart. We're also, as you know, working with the University of Rome. There's a very strong Italian component here. There must be at least 8 people from Italy from Italian campuses. Here's just one of them, and this is Giuseppe's campus. It is remarkable how much work the Italians are doing in power system engineering in Europe. And of course, this is what I'm most familiar with. My friends are Delft, Groningen, and I have some at the University of Michigan. So we're going to be reaching out to the European campuses and likely some of the Asian campuses. I'll let others, so our Japanese and Chinese friends, hash that out among themselves. Here we're looking at the Centers for Disease Control. We're looking at I believe this is Oak Ridge National Labs over here on the right. So it's not just college campuses, but how you design a new system that's downstream of the NEC, downstream of the Public Service Commission rules, but still has building premises wiring safety considerations is our scope of work, and it's a fairly clear thing to see. So finally, this is just our statement. This PowerPoint will be up on our website over here. I'm going to remind everybody that it is now crunch time for November 7th. We do have a proposal out there. I'll show it to you once. This is one where we're going to be looking. Actually, there's a link to this because we discussed it last week. We're really going after this table hammer and tong now. I gave you credit, Ryan, for making sure that we did everything we could to make sure that our electrical designers don't have to work with exceptions. And so now I've taken this table and I've driven ASHRAE numbers in the columns, and I take IBC numbers in the rows. I'm not going to get involved in any other industry that I don't know about, so I'm going to leave the banks untouched. That might be the Achilles heel of this whole proposal, but we still have another part of the process. So you can see that we're adding new facility classes that are indigenous or common in our industry, and we're using the ASHRAE. And so you and I know that when you do that, also I've given the committee a chance to see how the NEC lines up with the International Building Code. So I've gone through all these. So as reference, we build our case on this, and then of course, so that's what this constitute our justification for how we're going to be changing the rows on that table. But this also gives us a justification. This is the ASHRAE 90.1 requirement using the building method, which is the most similar to what was used in 2012. This is the numbers that we're going to be using. As you can tell, that we're at least half that we will never see if this standard is conformed to. And we continue to see the low density pattern descend as it has been over the past 10, 20 years. We will be taking a significant amount, and our designers won't be so skittish about using the exception. So that's what's on the docket, and that just went out in 2 forms last week. So any quick questions here? We have 2 minutes left, Ryan.
No. Can you send me that, though? I'd like to look at it.
Yeah, right. We'll take a look at all that's available here. We will be getting resources from IEEE. It's likely the IAS to make this more politically visible. It's quite a story about how this all happened. Again, we're a year into this, but we're still dealing with process issues. So we can't let process issues stop us from getting ideas on the table, and that's what's happened here. Finally, I guess I've given everybody a link here that they can look at. So once again, we've managed to pull off one of these on-site teleconferences, and I hope that one day we are going to get better audio, better visual quality. We hope this offers some insight, and we'd like to get people marking up the NEC now, striking out what they don't like and adding what they do like, and getting that out faster than stuff is coming at us. And that's my story. Anything else? Ready to close this workshop? Ryan?
Yes, I am.
Great.
3:29, right on time. Thank you, Mike.
Really? Okay. Thanks very much, Ryan, and I will see you.
Thanks, man.
There are a couple other guys here. Take care. We'll see you
All right, bye, guys.
in a couple weeks. Yeah, bye-bye.